A particle is moving along the x-axis. This is your velocity function. Your interval is from time up to this number, which is, got to use a calculator to figure what that is. I don't know what it is. And it says your initial position is 5. X of t is your position. Find the acceleration of the particle when t equals 3. Well, if we're given velocity, you should know acceleration is a derivative of velocity. So a of t, which is acceleration, is going to be v prime t. So what are we basically going to be looking for here? We're looking for v prime 3. We're trying to find the derivative of velocity at 3. And what you'll get, if you do use your calculator, you end up with, when you do this, you end up with negative 5.466. Okay. That is your acceleration at time 3. Now, how would you find that on your calculator? You'd have to use the in deriv button, and then you'd put in v of t, don't write v of t, depending on the function. You put the function in, and then you put x, and then you put what? 3. That would give it to you. You don't ever write this on the test. They don't care about this. Got it? Write this. This is what they want to see. This, they don't care about calculator language. They won't give you any credit for that. I'm just showing it to you. Calculator language is worthless to them. B. Find the total distance traveled for t equals 0 to t equals 3. So for the first 3 seconds, the total distance for the first 3 seconds. Now, if I want to find that total distance, what you got to realize, if you look at this picture right here, okay, this is a picture of velocities. If it's velocity, the area under this curve right here, this is positive, this area is negative, positive, positive, negative. So the area under this curve is the amount of distance traveled. So since this is positive, you're going to be going, if you make a little graph here, total distance traveled, if you make a little graph of this, here's what you'd look like. Alright, you're here. We start at 5, because that's what it says we start at. And for this particular problem, according to this graph, the area under the curve, again, is your position, is what the movement, the distance. So from 5, this is positive, so aren't we going this way? We're going this way to start with. Quite a ways. Then, when you get to negative here, negative values, don't negative values mean, oh, I turned around. So now all of a sudden, aren't we going this way? But isn't this less area than this? So we're not going to get all the way back to our original. And then, isn't this positive mean we turned around and went back the other way? But we're never going to get back to this far, so we're going to come back to here. And then you probably put arrows at these. Vectors with that distance, like little vectors. Remember from vectors? And then for this negative, don't we end up going back again? But did you see we keep getting smaller and smaller? And then we went back again this way. To kind of see how we're going back, forth, back, forth, back, forth, back, forth. Anywho, for B, they're saying the total position. Well, wouldn't the total position be to add up all these segments? Because aren't you moving back and forth each time? So the total distance would be to add this segment plus this segment plus this, all these segments. Now, but we don't have, we're going to 3, not to this. So, what you're going to do here is actually, I did all this explanation, but this answer is really simple. You're going to integrate from 0 to 3. You're going to integrate velocity. Now, when you integrate velocity, that gives you position. But don't you want to change all these negative positions to be positive positions? Because if you have negative positions, doesn't that take away? And you want to add all your positions. You want to add all these distances. Even though the distances are negative, you still want to add them. In order to add them, you have to make this an absolute value. Very huge. When you do total distance, you're talking the absolute value of velocity. Because you want the total amount of distance. So if you integrate this and do this, you would get it. And when you do that, you get 1.702. Now, in your calculator, it's ABS. There's a button, ABS, absolute value, under the math button. You use the absolute value button. Again, total distance traveled. Always, whenever you see the word total distance, be aware there's probably an absolute value. Be an absolute value on it.